So in the previous classes, we are done with these all topics, that is introduction to engineering mechanics, then basic concepts like particle, rigid body, force system. In this we have defined what is a force system, and we also defined the classification of the force system. What are the classification? That is coplanar forces, concurrent forces, parallel forces. In this way, we have classified the force system. In law of parallelogram, this law of parallelogram was used to find out the resultant. That is a resultant of two concurrent forces. Let us take if this is F1 and this is F2. To find out the resultant of these two concurrent forces, we used to use the law of parallelogram. We have used we have done with the composition, resolution of forces, and how to find the resultant of forces. The resultant of forces of coplanar concurrent forces. We are done with the finding out these coplanar concurrent force resultant. What we used to do, for example, if a number of concurrent forces F1, F2, F3, F4, these are all concurrent forces because they were meeting at a particular point. Let us take this as F1, F2, F3, F4. Now we used to resolve them into vertical and horizontal. Here also horizontal and vertical. We used to find out the summation of h, summation of v, and resultant r is equal to under root of summation of h square plus v square plus of other things. We used to use this formula to find out the resultant. Here the force system was a coplanar concurrent force system, so we were comfortably applied the law of parallelogram to find out the resultant. But when the forces are parallel forces, for example, these two are parallel forces F1 and F2. So here we cannot apply this law of parallelogram to find out the resultant. In such cases, to find out the resultant of these parallel forces, we need the principle called as Varignon's principle. This principle is based on the moment of forces. So let us know what is this moment of force now. So moment of force. The moment of force is defined as a product of the forces, is defined as a product of force and perpendicular distance of the line of action of the forces from a point is known as a moment of forces. So how we are defining a moment of force? A moment of force is defined as a product of a perpendicular distance from the force. That is, if this is force F, I want to know what is its moment about this given point A. So what I will do, I will extend its line of action. Here. I will drop a perpendicular here. So this is the perpendicular distance R of this force F. So the moment M is equal to force into perpendicular distance R. So now we are defining the product of force and the perpendicular distance. Which perpendicular distance? The line of action of the forces. The perpendicular distance between line of action of force and the chosen point. and the magnitude of a force. The product of a magnitude of force and perpendicular distance between line of action of this force will give me the moment. So there are two types of the moments can be positive moment, negative moment, and if the line of action passes through the chosen point, then there is no moment. Moment will become zero. The unit of moment is given by Newton meter. Since unit of force is Newton and the distance is measured in terms of meters, therefore the unit of force is Newton meter. So now question arises, what is the positive moment, what is the negative moment? For example, this is the force F acting in right hand side direction. If I want to know the moment about point A, so this is its perpendicular distance R. If I fix up here and I rotate this force, if this force starts to move in this, if force starts in this direction, what happens, since it is fixed here, it starts to rotate in this clockwise direction. So if the direction of this movement is in clockwise direction, if the movement acts in a clockwise direction, then it is taken as a positive movement. If the movement, let us take the point B here. If I want to find out the moment about this point, this is the perpendicular distance. If this moment, if the force is acting in this direction, what happens about this point? It starts to rotate in this direction. So this is acting in anti-clockwise direction. It is acting in anti-clockwise direction. So what happens? This is a negative moment. So this is the moment of forces. Moment of force is defined as the product of a force and the perpendicular distance of line of action of the force from the point is known as a moment of the force about that point. About A, this is the moment of force and it is acting in clockwise direction and it is taken as a positive moment. If the same force, if I want to find out moment about the point B, then the moment is acting in anti-clockwise direction, then it will become a negative moment. So the point of about a point, the point chosen is important. About which point you are choosing, the moment may become positive moment and negative moment irrespective of the direction of the force. So now let us go to VARIGNON'S principle. This VARIGNON'S principle is used to find out this. This VARIGNON'S principle. This VARIGNON'S principle is used to find out the resultant of parallel forces. So what this VARIGNON'S principle says is that if let us take there are few forces F1, F2, F3. If I find out the moment of these three forces F1, F2, F3 about point A, so I will draw the line of action of this force, line of action of this force, line of action of this force. So what are the perpendicular distance? I will take R1, R2 and R3. So F1 into R1 plus F2 into R2 plus F3 into R3. This is the total moment. Since all the forces are acting in clockwise direction, it is becoming plus here. Now, if I draw a resultant R and which makes a perpendicular distance of R, then this will be equal to R times of R. That is the moment produced by each force about a particular point is equal to the moment produced by the resultant about that point. So see here, principle of So according to Varignon's principle, the moment of a force about any point, the moment of a force about any point is equal to the algebraic sum of moment of its component about that point. That is, the moment of any force is about a point A is equal to, this moment is equal to algebraic sum of the component forces, algebraic sum of the moment produced by this component force F1, F2, F3, or it can be defined as the principle of moments states that the moment of the resultant of a number of forces, this is the resultant of force F1, F2, F3, resultant of a number of forces about any point is equal to algebraic sum of moments of the forces. So this is the algebraic sum of moment of forces of F1 into R1 is M1, F2 into R2 I can take it as M2, F3 into R3 I can take it as, this is the moment 1, this is moment 2, this is moment 3. So I am adding them up. Since all the moments are acting in a clockwise direction, I have taken them as positive. So is equal to the algebraic sum of the moments of all the forces of the system about the same point. So the moment produced by the algebraic sum of all the moments about a particular point is equal to the moment produced by resultant about that point. So that is the principle, that is the Varignon's principle, or we can even call it as a principle of a moment. That is, for example, F1 into R1 is a moment produced by F1 about the point A plus F2 R2 plus F3 R3 is equal to moment produced, that is R into, this is the perpendicular distance, resultant is given by capital R, and its distance, perpendicular distance is given by small r, so R into R is given the moment. So algebraic sum of all the moments, algebraic sum of all the moments produced by individual forces about a point is equal to the moment produced by the resultant of the forces about that point. Then it is called as a principle of moments, or Varignon's principle. So in next class we shall see how to derive or prove this Varignon's principle and its application to solve the problems. Thank you. So let us show here in this, while explaining I have shown you how this moment will act in clockwise direction and anti-clockwise direction. I will show a simple demo over here. So let us take, this is the force A. Let us take, this is the perpendicular distance. If I want to find out the moment about this point, this force about this point, So how the force will rotate? It will start to rotate in clockwise direction about this point. Okay, you can see the force is rotating in a clockwise direction. That is, the moment is acting in a clockwise direction. If for the same force, if I consider the point here, I consider this as the point about which I want to find out the moment. I will select this object. About this point, if I want to find out moment, see what is happening. It is rotating in anti-clockwise direction. This is taken as a negative moment. If for the same force, if I am choosing point here, it is acting in a clockwise direction. If I am choosing point here, it is acting in anti-clockwise direction. So if the moment is acting in anti-clockwise direction, then it is taken as negative. If the moment is acting in a clockwise direction about the chosen point, then it is taken as a positive bending moment.